So this is my Minecraft project on the 4-bit carry look-ahead adder. So firstly, I have a room here. Let me just reset these. Where you can essentially put in the values you want to add. So we have our A vector and our B vector, and then this represents the 8, 4, 2, and 1 for each bit in binary. And then you also have the carry in variable over here. So, and then these are the outputs that are generated and will display on this wall using these lamps as LEDs. So if we want to test some variables, we can do 1 plus 1, which should give us 2. And 1 plus 2 should give us 3. And 1 plus 4 should give us 5. And 1 plus 8 should give us 9. And then just to test an edge case, maybe we can do everything on, which would represent 15 plus 15, which should give us 30. Yep. And then we can also use the carry in, and that should generate the last bit, so it would become 31. And just to test the carry in with some more numbers, we can do 1 plus 1 plus the carry in, which should give us 3. And maybe 1 plus 2 plus the carry in, which should give us 4. Great. So now for the actual circuit. My design was based off of this image right here. So let's just do that. So if I were to zoom out all the way, then we could see that this essentially is in the same way where there's my first adder, second adder, third adder, and the fourth adder here. So to start with, I have my inputs coming in from this little area I made, where these top ones are my A vectors, or my A vector, and the bottom ones are the B vector. And basically these feed in over here and become A0, B0, A1, B1, A2, B2, and A3, B3, and they go all the way down to each adder. So to actually start looking at the diagram now, if we start up here where A0 and B0 are for this first XOR gate, that would be this right here. And this is P0 that's generated, and this is the intermediate signal. So it essentially goes down the entire way, and it will be used wherever else needed in the circuit. So next we have this AND gate, which represents this right here, and that's where G0 is generated right here. And once again, this will propagate down this entire line and can be used wherever needed. So next, while we're in the same adder, we can go to this next XOR gate, which is up right here. And what's feeding into that is this C0, so this is the C in, the carry in. And this also propagates down the entire line. So that's the XOR gate, and then this would be this AND gate right here. And then this would be the OR gate right here. And from this last OR gate, we can see that C1 is generated and S1, or S0. So this is S0, and S0 will go back to the output area over here. And the carry will be reused in the next block. So it will carry over here and feed into this next XOR gate, which would be right here. And basically the process repeats where the next S1 and or A1 and B1 come in and feed through the XOR and AND gates, and their intermediates pass down this entire line. And then those also feed into this XOR, this AND, this other AND, and then this OR, and the carry generates again and goes into the next block. And just to see the last case, we have the same XOR and AND gate here, and then we have all these. So all of these outputs, which are this entire block right here, get fed in as an input to this last OR gate. And since there's no more blocks after this, since this is the fourth bit, it will generate this last carry, which will go all the way back to the beginning. And that will generate the 16-bit. So if we were to test that real quick, if we basically turned all of these on, which would be 15, and then we did a carry in, that would should give us 16. Yep. So that was my project. Thank you.